All right, so yeah, so here we go. Yeah, this is you get this good old George Orwell quote from 1984, and yeah, I'd have to agree here with Mr. Fuzzy Face that yeah, that is a bit ironic, isn't it? That you got posting this. Alas, let's talk about calculus and something that we can control. Um, We have comparison tests we're talking about today. So first of all, we're going to start talking about the direct comparison test. The idea is that we're going to compare two different series directly. One of them, all the terms are going to be greater than all the terms in the other one. So each term that pairs up in this for B will be either greater than or equal to all the terms in A. And the idea is if we know that the greater term, the greater series converges, well, then the direct, the logical conclusion is that all the terms in the lesser series will also converge. That follows naturally. And then if we were to take a look at all the lesser terms, if all the terms in the lesser series, add up to something that diverges, well, then if you get something greater than or equal to that, then it has to at least be this, and so it's also going to diverge. And so this is just a natural thing. So let's take a look at something like this, where, well, we know because if you have a fraction and you add more to the denominator, well, then you know that this right here, 1 over 2 plus e to the n, 3 to the n, must be less than or equal to this. For all terms, right? That follows that this has to be less than or equal to this because the denominator is going to be bigger. Well, if that's the case, and we know since that n equals 1 over 3 to the n, this converges because why? Because power series. Okay, so if we know that this converges because of the power series, then this also must converge. Okay, that's the idea. And now we don't know what it's going to converge to unless you actually take those steps to figure that out, but we do know that it converges. All right, so let's take a look at this one. What would be the natural thing to compare this to? Well, it'd probably be natural to compare this to, maybe 1 over radical n. And because you can say, okay, well, I know that this would have to be greater than this one. Okay, obviously this would have to be greater than this because the denominator is bigger. And so if the denominator is bigger, then we're going to have smaller values. However, this series, 1 over radical n, diverges, okay, by the p series. Okay, we know that this diverges by the p series. So if we know that something diverges to something less than that, does that follow the direct comparison test? No, it doesn't. We'd want to know that this would be greater than that. That's the only thing we can do. So instead, maybe we consider 1 over n and 1 over radical n plus 2. Okay, so let's take a look at this. Well, if n is 1, so let's say we got 1 over 1, and we have 1 over radical 1 plus 2. Well, is there something we could say there that, this is, we have 1 over 1 and 1 over 3? Well, that's greater than that. Well, what about 1 over 2 and 1 over radical 2 plus 2? Okay, well then that's still greater. 1 over 3 and 1 over radical 3 plus 2. Still greater. 1 over 4 and 1 over radical 4 plus 2. Well, these are equal. What about 1 over 5 and 1 over radical 5 plus 2? Now we're actually kind of getting somewhere because this is greater. And then 1 over 6 and 1 over radical 6 plus 2. Oh yeah, this is definitely greater. So after n equals 5, so after n equals 5, we know this is going to be true. And it's not the, it's not the problem about what's going on before that that's really the issue. I mean, 1, 2, 3, and 4, it's like, okay, well, I can add up these and get a nice number. It's not, the reason that 1 over n diverges is not because of, this, what, you got 1 plus a half plus a quarter, that's 1 3/4, plus a third, 7/4 plus a third comes out to be, this is what, 21 over 21 and 4, so 25/12. Is that 25/12 that the reason that this breaks? No, it's not. So we know that since this n equals 5 to infinity of 1 over n diverges, well, so does this. Okay, 1 over 2 plus radical n. And so you could kind of, that's where we go by that. But however, there's probably got to be something a little bit better. There's going to be something better. And so sometimes the comparison series is like, well, that doesn't quite fit. Maybe there's something better we can do. And there is something better. So we have the limit comparison test. Okay, we got the limit comparison test. Like, okay, so this idea is if we have all the terms in each of our series are both positive, and we can take the ratio between those two, and we take the limit as n approaches, as this approaches infinity, and we get some positive L value, then we can say that these two things are going to go together. And the limit comparison test is very, very useful. I like this one. I like this. This is one of my favorite ones. This is, I would say, this is my, like on the level of, like Axu sort of like favorite. Not my ultimate favorite. This isn't my Psyduck. This is my Axu. So so it's really good. Power series. This is definitely that's my Psyduck. So now this one right here. So we look at this and we're like, okay, well, what is it similar to? Okay, this is similar, because this is similar. This should be 1 over n. This is similar to n equals 1, because they're both linear in the denominator. They're both linear in the denominator. And so you're like, okay, well, let's now, does it really matter which one's a or n? No, it doesn't matter, because either you're going to have, and well, I'm going to show you why it doesn't matter. So let's just see why it doesn't matter. So limit as n approaches infinity. Let's say that this is a. So we do 1 over 2n plus 3 over 1 over n. Well, then this gives us the limit as n approaches infinity of n over 2n plus 3, and we get 1/2. But if we did the opposite, we say, okay, well, this is a and this is b. All right, well, then 1 over n over 1 over 2n plus 3, and then we get the limit as n approaches infinity of 2n plus 3 over n, which then gives us 2. Both of these are positive numbers, and so both of them it happens. So it doesn't matter which one you pick as A or B. It's very, very forgiving. So now with that, we'd say, okay, well, I know this diverges, and so since we'd write since 1 over n, n equals 0 or n equals 1 to infinity. So since this diverges, and the limit as n approaches infinity of 1 over n over 1 over 2n plus 3 equals what this one was 2, whatever. It doesn't make any difference which one you pick. By the limit comparison test, we'd have n equals 1 to infinity, 1 over 2n plus 3 also diverges. Okay. And so now let's go back to the other one where we like maybe you weren't 100% convinced on that other one. And so you're like, you know what, I don't think that was really that good of an answer. Well, let's use the limit comparison test for that other one. So we had 1 over, let's see what it was. Before it was 1 over 2 plus radical n. So let's compare again, because we know from the p-series that 1 over radical n, we know we're going to compare it to this because we know from the p-series that this diverges. So let's do this. Let's do the limit as n approaches infinity of 1 over 2 plus radical n to 1 over radical n. Okay, well then we get the limit as n approaches infinity of radical n over 2 plus radical n, and that's going to be 1. Okay, so there we go. So by limit, okay, compare this, which, and let's just note that, which diverges by p-series. Okay, so by p-series. So there's your Snorlax right there. P-series is like your Snorlax. Okay, so by limit comparison test, n equals 1, infinity, 1 over 2 plus radical n also diverges. So you got these different things, and so if you know one thing, then you can figure out the other. And if there's something that's really similar to it, then you could go from there. You could do this with you could do this with all sorts of different ones. Like say we had the 1 over n squared plus n. Like let's say we had this one. You're like, well, I know that this is, you can use either one. You can use either one for this one. However, if we wanted to do 1 over n squared minus n, okay, well, unfortunately, this is going to be greater than, this one's going to be greater than or equal to our 1 over n squared. So we can use, this one, you can use either direct or limit. On this one, we can only use only the limit. Okay, and so yeah, and so you have these options, and you have all these different things, and again, it's like, which thing are you going to use, and so you just kind of mess with it and see. We're going to experience these. You're going to learn your different tests. You're going to be more familiar with them, and yeah, just like you guys said before, it is a lot like Pokemon, and because more so than you even imagined when you guys were even like we were kind of joking around about it is there. I mean, there's so many different moves that you can use, and some things are going to be useful and some things are not, and so you just have to learn what's going to work and what's not. Some things are going to be it's like the direct comparison test, or the limit comparison test. The limit comparison test is incredibly useful. This is really useful. It's not as awesome as the power series, it's not as awesome as a P series, but it is very, very helpful. So, all right, so try those out and see what we got. Let me know.